In this problem, we're asked to draw the Lewis structure and to predict the molecular shape of this ion. The first step to drawing the Lewis structure is to count up the total number of valence electrons. We have one atom of carbon. It's in group 4, so it contributes 4 valence electrons. And we have 3 atoms of sulfur, each of which contribute 16 electrons, so we have 18 electrons from sulfur. Now we need to account for the fact that we have a -2 charge on the ion. A net -2 charge means that we have an extra 2 electrons. So when we sum up our total number of electrons, we have 24 E's, which will group into 12 E pairs. Now the first 3 sets of electron pairs are going to be used to connect these atoms. Then we're going to use the remaining electron pairs to complete the octet of the outside atoms. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now when we look at our outside atoms, we see each of our outside atoms has a complete octet, 4 E pairs. When we're counting our electrons, it's important to remind ourselves that the bonding electrons count towards the octet of each atom involved in the bond. So that's how we get 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8 electrons around each of the outside atoms. When we look at our center atom, we see that our center atom is electron deficient. It only has 1, 2, 3 electron pairs. Therefore, we're going to need to make one double bond. What this does for us is that it allows an extra pair of electrons to do double duty. Let's recount the electrons around each atom. This sulfur has 2, 4, 6, 8. This sulfur has 2, 4, 6, 8, 2, 4, 6, 8. And the carbon atom now has 2, 4, 6, 8 valence electrons. Now all of the 4 atoms have satisfied their octet. The molecule is of the type AX3, i.e. the center atom has 3 bonding regions and 0 non-bonding regions. Therefore, its electron pair geometry is the same as its molecular geometry, trigonal planar.